Student, today we shall discuss the how to represent the different relationship that exist between two different entities. The degree of relationship is the number of frequency times instance in one entity is related with the other entities. The relationships may be binary, ternary, and more than that also one to n, and we shall discuss the different type of relationship and how they are represented in ER diagram. Suppose there is a student entity and program entity which are related to each other by a registered for function with each other. Means a student has opted one program and he would relate to the that program. But uh, here this relationship may be binary, ternary, or one to n. For example, the teaching department of university is interested in tracking which subject each of the student has completed. This leads to a relationship called complete between student and subject entity because every student will opt for at least one subject. Okay. It means and every uh, this is many to many relationship. Each student may complete more than one subject and more than one student may complete with each subject. Here we can see that there is an arrow branching at the end of the connecting line between completes and subject and student and complete. Means a student can opt more than one subject and a subject can be opted by more than one student. So the type of relationship here that exists is many to many. The many to many relationship is represented by in this way, like the branching on the both hand. So here there may be multiple instances of the students may be connected with the single instance of the subject, or there may be multiple instances of the subject. They may be related to a single students. So this kind of relationship is called the complete relationship. Now we should discuss how different degree of what is degree of relationship and how they can be represented. The degree of relationship is the number of entity type that participate in that relationship. Uh, the degree of relationship is the number of instance which participate in the relationship. The relationship completes as shown just before this slides is of degree 2, 3 uh, since it is possible that two students may opt for a single subject or one subject may be opted, more than one subject may be opted by a single student. So the degree of relationship represents that how many instances of one entity are related to the one instance of the another entity. Or number of instances that participate in the relationship. We can also say that it represents the number of instances that participate in relationship. So it may be unary, binary, or ternary, and more than that also. So we shall discuss it one by one. The unary relationship. This is called the recursive relationship. Means an entity is related one to one uh, to itself. It is a relationship between the instance of one entity type. And instance is a single occurrence of an entity. Means if there are multiple instances of a single entity, there are instance there could be, but when one instance of entity is related to itself, it's called urinary. And what is instance? Instance is a single occurrence of entity. So if in class there is student, there are students, so we can say that in 60 students, then we can say that in the class there are 60 instances of the student. Similarly, if in the library there are books, and books will be the entity, and in library if there are 10,000 books, then yeah, or 1,000 books, then we can say that there are 1,000 instances of the books. There may be many instances for an entity. So an instance can be 100,000, whatever. uh, Now suppose we are showing a one-to-one relationship between the entity person. That is, a person is married to uh, another person, but as per rule, one person, as per legal rule, one person can marry with only one person. So here, each person may be, but okay. So, but now there is another relationship in which is friend of student is friend of a student. Student may be friend of student, but there is no restriction that, or legal restriction like marriage, the one student can be friend of only one student. So one person may have five, six, seven, whatever. So in case of marriage, the restriction is that it should be the one-to-one relationship only. But in case of friend, the student may be friend of multiple person students. So the first one, the marriage relationship, is a one-to-one relationship, and the friendship relationship is one-to-many relationship. So one-to-many relationships related by the branching as shown in this diagram. Now the binary relationship. It is a relationship between instance of two entities types, and is the most common type of relationship encountered in ER diagram. Now we shall take few examples. The first one-to-one indicates that a student is assigned a student ID, and each student ID is assigned to a student. But we know that college, every student gets a student ID, and every student is allocated only one student ID. This is a kind of one-to-one relationship because no student can have two student ID. Similarly, for roll number, a student may have one roll number, and every student will have a unique roll number. No student could share a single roll number. So the relationship between a student and student roll number is one-to-one relationship or urinary relationship. Similarly, student to enrollment ID is also a urinary or one-to-one relationship. But when the student, and we draw a relationship between student and program, in this case, a student may opt multiple subject, and a single subject can be opted by a multiple students. So on both hand, this relationship is many to many relationship. So this is the one to many relationship, because one student may opt for multiple and one to many relationship. Uh, this could be a case of many to many relationship because a student may register n number of subject, and a student subject may be registered by the many student. So this lies under the case of many relationship also. But if for some subject you have decided that a student can opt for a single subject, then it would be case of one-to-many relationship. Because suppose you have decided that among these set, a student can select only two electives, or student would select only student would select only one elective out of these subject. Then in that case, student will opt only one relationship, but one subject may be opted by the multiple student. So from the okay, so from student to subject, it is one. This is case the many to many relationship. So for diagram in ER diagram, we shall represent this. The unary relationship is represented by the single line, and one-to-many relationship is represented by uh, case one-to-many is the branch is the relationship which could have multiple instance related to a single entity. A single instance of a first entity is marked by a fourth symbol at the end. For example, uh, in a program there could be multiple students, but if you have decided that the student would opt for only one course program here, not subject. Here I have suppose student is of computer science branch, then he can only choose sub computer science, but he cannot opt for the subject of civil branch, electrical or mechanical branch. Then in student can register in only one branch, but in one branch there could be multiple students, or is multiple instance of the student. So the on the student side there would be a fork symbol, but for the program, uh, in one program student cannot opt for two. One student cannot opt for multiple programs, so it is not forked at the program end. So what it is kind of one to many relationship. Okay. But if we draw the relationship between the subjects and student, then suppose we have decided our branch. Then in computer science branch, suppose I'm taking, there could be multiple subjects and there are numbers of students. So for every elective, multiple student can select the same elective, and same elective can be chosen by the different number, multiple students. So there is a choice on both hand, and this kind of relationship is called many to many relationship. And in this kind of relationship, a fork symbol is marked on the both hand of relationship symbol, that's represented by the diamond shape. So the first case was one to one, where which was student to student ID. Second was program or branch to student, that is one to many, because one branch may be selected, one student may select only one branch. So uh, it is one to many relationship. And student to subject, this is a many to many relationship. Ternary relationship, it is a simultaneous relationship among instance of three entity types. In figure 3.14, the relationship may have provide the association of the three entities, that is teacher, student and subject. All the three entities are many to many relationship participant. There may be one to or many participant in ternary relationship. Okay. In this, there are three entities which are related to each other by a single relation. Student, teachers, and subject. These are the entities, and there could be multiple instances of all these. There in the college, there could be multiple teachers. There could be multiple instances of students and subject also. So all these relationships here that we have taken are many to many. And this is the relation in which uh, among the three entity set is called the ternary relationship. The relationship may have provided the association between the entities. Here, there could be the multiple student which a teachers can teach. A teacher can teach multiple number of students. So this is one to could be one to many, but a student may be taught by the multiple teachers. So it is he may have many teachers because different subject will be taught by the different teachers. So the relationship is many to many between student and teacher, as a teacher can teach multiple students, a student may be taught by multiple teachers. Similarly, a teacher may teach multiple subject. It is possible more than one subject also, and a subject may be taught by two different teachers in two different sections. So the relationship between the teachers to subject is also many to many, because teacher may teach more than one subject and a subject may be taught by more than one students. If they are a subject is taught in many sections, are taught by many sections, then different teachers may teach the same subject. Similarly, between student and subject, a student may opt multiple subject, and similarly a subject may be opted by multiple students. So all these relationships share a many to many relationship, and since there are three entity sets which are related by a single relation, so this is called the ternary relationship. So, like this, n entities can be related with the same relationship, and it is called an array relationship. Suppose if there are 10 entities that are related with each other through a relation, then this could be called 10 array relationship. Suppose that there are two entity types, A and B, that are connected by a relationship. The cardinality of a relationship is the number of instances of entity B that can be associated with each entity of entity A. Uh, the cardinality of the relationship is the number of instances of entity B that is associated with each instance of entity A. It means it's also a kind of degree or cardinality are same word. Suppose there are two entity A and B, and if there are an instance of A that could be related with the uh, one instance of the entity B, then this would be called, and the cardinality would be, and would be equals to, we can say that one to many. So this called degree is our cardinality, are same type of same terms that can be used to define the nature of relationship. The minimum cardinality of, but there could to limit the number, we use a term and minimum and maximum. The minimum cardinality of a relationship is the minimum number of instances of entity B that can be associated with each instance of entity A. if the number of student available for a subject is 0, we say that subject is optional participant in register for relationship. Suppose if subject is elective and no student opt for that subject, then we can say that its minimum cardinality is equal to 0. When the minimum cardinal, but there for the, suppose the maximum cardinality is the maximum number of instance that of one entity can be related with other. So the 0 is represented by the two line by a line, two parallel lines on the relationship, means the minimum cardinality is 0. And by the fork symbol at the end represent the many cardinality, many maximum cardinality. Now the representation of cardinality. Take a look here. It's here mandatory one cardinality. The two parallel lines represent that the cardinality should be at least 1. And mandatory many cardinality, n is a number for upper limit if one exists. If means if a single line is marked by a symbol represent an associated n number represents that the upper limit is n and it cannot be greater than n and start from 1 to n. But if there is a small circle symbol along with a line, it means that cardinality could be 0 or 1. Similarly, if a small circle along with a fork symbol represent that cardinality could be from 0 to n. So once again, two parallel line represents one cardinality. Single line with n symbol represents one to many relationship and maximum cardinality is equal to n, and small circle with line crossing line represents 0 and 1 cardinality. Small circle with fork symbol represent 0 to n maximum cardinality. Each entity type has a set of attributes associated with it. So the attributes are represented by the eclipse symbol. Suppose a student may have student ID, student name, address, phone number, then all these attributes are represented in ellipse or oval shape symbol and it's presented like this. Similarly, the employee could have employee ID, employee name, and address, and its attribute is a property or characteristic of an entity that is of interest to the organization. And attribute is a property of the entity that is of interest of the to the organization. So it is represented by the oval symbol. Notation is like this in the ERD. It is represented with an initial capital letter and followed by lowercase letter. And okay, now the candidate key. Every entity type must have an attribute set of attribute that distinguishes one instance from the other instance of the same type. Uh, the attribute set that is used to identify a particular entity uniquely is called the candidate. Candidate key is an attribute or the combination of attribute that uniquely identifies each instance of an entity type. Okay. Some entities may have more than one candidate. One candidate key for employee is employee ID. Second is the combination of employee name. Suppose for employee, could be multiple attribute associated with it. Employee ID, employee name, and address. Among these, employee ID would be the attributes which will uniquely identify a particular employee. There could be multiple employee who will have the same name or they could reside on same address, but the employee ID uniquely identify a particular employee. So there could be no doubt if we mention employee ID. So this uh, attribute or could become the key to identify, and this would be the candidate key. And it is also called a identifier. Uh, but out of these candidate key, the identifier which you choose to uniquely identify entity type is called identifier or primary key. The notation for the identifier is attribute with its name underlined. Okay. In the same thing we call primary key when we use the this identifier or candidate key. For example, in this diagram, a student may have many attributes, identity may have many attributes, student ID, name, address, phone number. Here, the student ID is the identifier for this entity, and this could be marked by underline within on below the student ID to mark that the student ID is the attribute which can be used to uniquely identify a student. Uh, The data flow diagram and the EI diagram each highlight a different aspect of the same system. As a consequence, there are one-to-one correspondence that must be checked to ensure that ER diagram and data flow diagram are consistent over all applications. This suggests that it is desirable to use both methods such that we can view the logical issue from the two perspectives generated by the two approach. Okay. So this is all about the ER diagram relationship.